Today we are going to discuss about the photoelectric transducers. Photoelectric transducer Photoelectric devices can be categorized as photoemissive, photoconductive, or photovoltaic. In photoemissive devices, radiation falling on a cathode causes electrons to be emitted from the cathode surfaces.
Hmm.
In photoconductive devices, the resistance of a material is changed when it is illuminated. So this photovoltaic cell generate on output voltage proportional to the radiation intensity. The incident may be infrared, ultraviolet, gamma rays, X-rays or visible light. So next topic is photomultiplier tube. The photomultiplier tube consists of an evacuated glass envelope containing a photocathode, an anode and several additional electrodes termed diodes, each at a higher voltage than the previous diode. This figure illustrates the principle of the photomultiplier, and electrons emitted by this cathode and attracted to the first diode. Here a phenomenon known as secondary emission takes place. Then when electrons moving at a high velocity strike an appropriate material, the material emits a greater number of electrons than it was stuck with. And in this device, the high velocity is achieved by the use of a high voltage between the anode and the cathode. The electrons emitted by the first diode are then attracted to the second diode, where the same action takes place again. Then each diode is at a higher voltage in order to achieve the requisite electron velocity each time. Hence, secondary emission and resulting electron multiplication occurs at each step with an overall increase in electron flow that may be very great. Then amplification of the original current by much as 10 raised to 5 to 10 raised to 9 is common. Luminous sensitivities range from 1 ampere per lumen or less to over 2000 ampere per lumen. Typical anode current ratings range from a minimum of 100 microamps to a maximum of 1 milliamp. The extreme luminous sensitivity possible with these devices is such that for a sensitivity of 100 amps per lumen, only 10 raised to minus 5 lumen is needed to produce 1 milliamps of output current. Then these magnetic fields affect the photomultiplier because some electrons may be deflected from their normal path between the stages and therefore never reach a diode or anode. Hence the gain falls. To minimize this effect, mu metal magnetic shields are often placed around the photomultiplier tube. The next, the photoconductive cells or photocells. The devices discussed above achieve an electric output by photoemission. Another photoelectric effect that is very useful is the photoconductive effect. In this effect, the electrical resistance of the material varies with the amount of incident light as shown in the figure. The photoconductive material, typically cadmium sulfide and the cadmium selenide or cadmium sulfoselenide, is deposited in a zigzag pattern to obtain a desired resistance value and power rating, and which is separated two metal coated areas acting as electrodes, all on an insulating base such as ceramic. The assembly is enclosed in a metal case with a glass window over the photoconductive material. Photocells of these types are made in a wide range of sizes from 1 by 8 in diameter to over 1 inch. These small sizes are suitable where space is critical, as in punched car reading equipment. However, very small units have low power dissipation ratings. And a typical control circuit utilizing a photoconductive cells is illustrated in this figure. The potentiometer is used to make adjustments to compensate for manufacturing tolerances in photocells sensitivity. When the photocell has the appropriate light shining on it, its resistance is low and the circuit through the relay is constantly high enough to operate the relay. When the light is interrupted, the resistance rises, causing the relay current to decrease enough to de-energize the relay. Thank you.